So I mentioned that the load is roughly 71%, and that is the same weight regardless of where you are throughout the range, but the actual torque or the actual resistance you're going to feel is going to change and actually get heavier as you go down, because as you fold up, the moment arm of that line of resistance is increasing in each joint. The same as if you lower yourself in a squat. The bottom of a squat is harder than the top of a squat due to the change in torque, which is reflective of the change in moment arm, not necessarily the change in the amount of force itself. But, this is an important but, most people don't get that they can alter resistance profiles. How many times have you heard people out there saying, oh, you got to move full range of motion, you got to move full range of motion? Well, A, full range of motion should be determined by the individual and the ability of their joints and muscles to perform that range, not by your externally viewed, chosen, arbitrary range you think is important for everybody. That's number one. Number two, just because you moved what you think is full range of motion doesn't mean there was even close to full range challenge. Because every single exercise, even one like this, that is, as far as the machine is concerned, same load at the top and same load at the bottom, it's a different torque of resistance on you at the top and the bottom. Even a linear resistance has a variable resistance. Most people don't seem to understand that. Every cable exercise is a variable resistance for at least two reasons, one of which is moment arm. Everything in the gym, a dumbbell is variable resistance for at least two reasons as you move it. So what you could consider is, if I really want this person's full available range, their client-defined available range that they can control and that they own, and if I want a full range challenge, then I have to modify the resistance for where they're weaker at one place and maybe heavy or stronger in another place. I need to modify my resistance profile to match their strength profile. Now I can do that by simply using a heavier weight at the top and move shorter, and a lighter weight at the bottom to match the bigger moment arms. And I can make that work, but you also can do it by understanding just a little bit of physics or the properties of the devices you're using. For example, we mentioned the inertial effects of this thing earlier being influenced by your acceleration and deceleration rate, not by the weight, the angle. But something else you can do, and we do it all the time, and there's a lot to learn about it, so I just don't want you running around messing up with this thing and hurting somebody. And it's not just to make things easier, it's to make them appropriately challenging at each point in the range. We will often use tubing, loops such as this, and calculate exactly how much it provides as you increase it from this length to 200% of its length, or from this length to maybe 300% of its length, where it's going to be pulling at, close to 100 pounds. But you can offload at the bottom. So as I mentioned, as this thing goes down, we have some devices up here where you can choose the amount of tubing and make it so that as you go through your excursion, your specific range, how much do you want pulled off at the top? And you, of course, want the full load of the weight. How much you want pulled off at the bottom, and you want the full load of the weight at the top. You don't want it pulled off at the top. You need to be responsible for that. And how we would make that occur. And the cool thing about tubing, not only is it pound per pound pulling something off at each point in your range, it almost provides what I like to call an inertial dampening effect. I mean, it also slows the thing. So it does help you with the inertial component. Now, having said that, I think it's real important to realize that controlling inertia is an important part of a training adaptation. So I wouldn't always use this version of offloading where you don't get the inertial thing. It might be great for somebody with arthritis, great for someone with patellofemoral problems, because of the increased forces they usually have when they decelerate at the bottom. It might be perfect for them, but for an awful lot of people also, I'm going to want them to deal with the load and its full inertia at the bottom. I'm going to change the profile by adding as they go up. So I'm more apt to use something like maybe this, and a stair-stepped webbing device, so I can change it based upon their excursion. And at the bottom, this will have some slack in it, just a little slack at the bottom of their excursion, so that they're dealing with this load and its inertia, and having to control it and decelerate it, just like pulling into a parking spot right up against that parking block, super controlled out of there. Then they can use a little more speed throughout the thing. But those inertial forces are huge. And if you think it's all about explode, 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 you don't understand forces, and you sure don't understand knees and patellofemoral joint. But then as they go up, this is incrementally increasing and adding load at the top. So at the top where they're nearly balanced, and you realize when your leg is near straight, the forces going through it create zero torque. So you can add load via something like this to offset the decreasing moment arm at the knee and the hip as you head towards the top. And if you haven't felt something like that, used specifically with strategically used tubing, not just getting tubing with a handle on each end and wrapping it around there, that doesn't work out very well. But the more you learn about this, and that's why we spend so much time on it in our mastery program, because it's such a useful device, especially for anybody with compromised joints and And that's so many people that we end up dealing with. They appreciate what we offer more than anybody else because everybody else is just beating the crud out of their joints. We're actually helping them with their joints.